intelligent, bright mind that I've come across in conferences internationally. I remember in Monbio listening to you about depleted uranium and the long-term effects of radiation. So that's Professor Chris Busby is going to be our first speaker.
Okay, hello. I was originally asked to debate this issue with George Monbio, and so since he isn't here, he didn't want to come, I'm going to debate it with this little TV camera here. And so we'll put what I have to say up on YouTube, assuming everything works. I've been to Fukushima. I was there quite early on, and I've measured the radioactivity there, taken a gamma spectrometer there, and talked to the people there. And I more or less know what's going on, and I've been on the ITV and HTV and so on, and right from the beginning I said that this was a very serious matter, and that it was worse than Chernobyl. And of course in those days everyone was saying it wasn't as bad as 3 Mile Island, so I have the advantage of the moral high ground after all this time, since I was right all along. But I'm not going to talk to you so much about Fukushima, because if I were to be debating this issue of nuclear power and the effects of Fukushima, or the effects that Fukushima should have on decisions being made about developing nuclear energy, then what I would concentrate is on the health risk, because this is what I know about. This is what I've studied for 20 years, and this is what I've published many research papers on, and carried out a lot of studies. The latest one being in Fallujah, Iraq, where we found very high levels of cancer and genetic damage and congenital malformations, which we now know are caused by uranium, which we measured in the hair of the children. So what I have to say to you is from the vantage point of someone who has studied this issue for a very long time. And so in the 20 minutes that I have available, I may have to bore you, but I think it's necessary to give you an account of the health effects of low doses of radiation from these novel substances, which only appeared on the planet after the fissioning of uranium in 1945. So I'm going to split my, in the time I have, I'm going to split this into, let's see, 42, 20, so about, a little bit past 8 then, okay. I'm going to split it into 3 sections, really. The first section is going to be roughly about radiation. I'm sure a lot of you know about radiation, but some of you may not. And then I'm going to go to the epidemiology. So I'm going to go historically through the observations that have been made about the health effects of these substances since they first appeared on the planet, about 1950s, with the beginning of the weapons testing in the atmosphere. And then lastly, I'm going to talk a bit about the politics and the cover-ups and the skullduggery and the fixing and the most unbelievable criminal activity of the people, many of the people involved in this area, trying to keep this ship afloat in the face of unequivocal evidence from science that the health models that they use to regulate the levels of exposure are massively incorrect. And because I'm unaccustomed to speaking lately without a PowerPoint, I've actually written some of this stuff down, because it's very easy for me to just waffle endlessly on. I seem to have some kind of organ in my body, a sort of waffling centre. So I can more or less speak on any issue, forever. So I meant to look at these notes in order to ensure that I make sure that you hear all of it, or as much of what I can get in as possible. So you see, I've already waffled away 5 minutes. Okay, now what you have to know, first of all, is that the current risk model that's used for assessing the effects of low doses of radiation is wrong, and it's a model that was developed in 1952 by an outfit called the International Commission on Radiological Protection, the ICRP. And this outfit has for a long time been in Sweden, in Stockholm, but it's now moved to Canada since its main man, the Secretary Jack Valentin, resigned in 2009, and we'll talk about that later. Now, the risk model of the ICRP is a very simple one. It's based on the idea that you can measure the effects of radiation millisieverts. That's absorbed dose effectively. And it's basically a physics-based idea of energy per unit mass. So in other words, they measure the amount of energy that's transferred to your body from the radiation, and then they divide it into your mass. And so many joules per kilogram gives you your absorbed dose. Now there are various kinds of radiation. There's photon radiation, like light, and there's particle radiation, like beta particles and alpha particles. But actually, the effects of radiation all are transferred to the body in terms of charged particle tracks. So even if you're irradiated from outside by a gamma ray or an X-ray, what happens is that those X-rays or gamma rays are absorbed and they produce photoelectrons, or they produce electrons of some sort, and these electrons are like like little bullets. You can imagine them flying through the tissue. And as they fly through the tissue, they create ionization, so they create like little sparks. You can think of it as little sparks, and these little sparks can attack tissue. And if the tissue that they attack is the DNA, then they can cause fixed mutations. Many of these mutations are repaired, but they can cause fixed mutations, and these fixed mutations can lead to the death of the cell, or they can lead to more serious effects. And certainly in germ cells, in the egg and in the sperm, they can lead to congenital malformations, or miscarriages, or heritable effects of some sort. So you have to therefore, yes, so the health effects are then, according to the ICRP, couched in terms of cancer. So in other words, they take a certain amount of absorbed dose and they say this amount of absorbed dose produces this amount of cancers. And this is effectively what's called a risk model. So when they're trying to work out how much radiation you can stand or what sort of dose limits there should be, they use this risk model, and it says that you can't have a certain amount more than a certain dose. Now this risk model is entirely defined in terms of external radiation. It's defined in terms of radiation that comes from the outside, photon radiation, radiation which is from gamma rays or X-rays. And the problem is that most of the serious damage is not caused by those sorts of radiation, it's caused by internal radiation, by substances which were produced with the fissioning of uranium in 1945 and then in 1952 and then between 1959 and 1963 with the weapons fallout, and then later on with a whole series of accidents and releases from nuclear power stations culminating in Chernobyl, which produced an enormous amount of this material, and it spread all over the planet. So all of the food that you eat now contains these radionuclides, and when they go inside you, they can cause damage which is not easily defined in terms of its absorbed dose. And the reason for this is that the energy density, if you like, the number of little tracks of bullets that there are, varies with the kind of material that you ingest or inhale. I mean, I'll give you an example. A good example is the hot particle. Now, after Fukushima, my colleague and I, we looked inside car air filters, vehicle air filters. Now, vehicles breathe air. So you can take the filter out of a car and you can pull out the material inside the filter and you can put a photographic plate on top of it, and you can then look to see what is on this photographic plate. And what you find is that the radiation is concentrated in little splodges, like little dots. So these dots represent the existence of little particles of material which are extremely radioactive. Now, if you inhale one of these particles of radioactive material, as of course the Japanese are doing all the time, it will go into your lungs and then it will be translocated into your lymphatic system and go somewhere in your body where it will cause an enormous amount of energy to be produced at one point in your body, but there will be no energy anywhere else. So to use the ICRP risk model would be false under such situation. What you're doing is you're diluting that energy into the whole body. It's so many joules per kilogram, but because you've diluted it into the body, the doses are very small. So the ICRP model that's being used in Fukushima at the moment is couched entirely in terms of external radiation. So what they say is that if your dose is less than a certain amount, so many millisieverts, you are okay. But actually, we know from Chernobyl that you are not okay. The effects of the Chernobyl accident in the territories where these materials were distributed, and in fact even as far as Wales, where I live, gave significant increases in ill health, not just cancer incidentally, but a whole range of illnesses. So the first thing is that the ICRP risk model is incorrect because it doesn't distinguish properly between external and internal radiation. And a good way to look at this is to imagine sitting in front of a fire and warming yourself and considering the number of joules per kilogram that you get, which will make you comfortably warm, and comparing that with the same number of joules per kilogram that you would get if you reach into the fire and take out a hot coal and eat it. And you can see that this would be the same dose under the ICRP risk model. Now in 1998, with the assistance of the Green parties in the European Parliament, I helped to set up a new group called the European Committee on Radiation Risk, the ECRR, and this is an alternative committee to the ICRP. It has about 40 eminent scientists from many countries in Europe, many of them from the ex-Soviet Union territories, and we have produced our own report, which there are copies of this available at the back if anybody wants to buy this. The latest one was in 2010. And this report accurately predicts the levels of cancer and ill health as a result of accidents or exposures. And in fact, you might want to know that in terms of Fukushima, we have used this to analyze the effects of the Fukushima contamination in the 200 kilometer radius of the accident center. And it's easy to predict using a number of different methods that there will be about 400,000 cancers produced as a result of the Fukushima accident. And that's a low level, that's a minimum number. It's probably going to be worse than that. We haven't brought in Tokyo because we now know that, of course, it's spread much further than that. So we're talking about a very, very serious matter. But as I will show you later on, as I continue, in fact, you don't need to have a Fukushima accident in order to have people die, because we have looked at people living close to nuclear power stations in this country, and it's quite easy to show using standard statistical methods and using the data that's available from the Office for National Statistics that there is a statistically significant increase in adult cancers downwind of nuclear sites in this country. Hinkley Point in Somerset, Bradwell in Essex, Trawsfynydd in Wales, and various other sites that we've looked at. And in fact, I've recently looked at Wilbur for the Welsh television, and we've found the same effect there. So in fact, it's very easy to find. So what happens in this area is we don't have science anymore. The area of the consideration of the development of nuclear is no longer a scientific matter. When I came along in the 90s and started this lark, I sometimes wish I hadn't, it was all about how the anti-nuclear movement were people who didn't understand science. And the scientists used to get trotted out in their white coats and then later on in their hard hats or whatever uniform they were using to tell us about how we didn't really understand science. But actually this is all turned on its head now. The science is on our side. And what they do now is they just attack us. I've been personally attacked on the internet. My funders have been written to, my universities have been written to, the journals that I publish in have been written to. And when I go into court, which I do a lot, and I've probably won about 20 cases on this issue now, and the Ministry of Defence, and very often I'm up against the Ministry of Defence, they send their people in there, and what they always do is they never address the science. They always attack me as, Busby, well-known nutcase, and all the rest of it. But you can't get away with that in a court. In a proper court, the judge will look at the evidence, the jury will look at the evidence. So you can do that out here, you can do that on the internet, but in a legal court case you don't get away with it. So having established, or I hope established in your mind in the short time available, that there's a problem with the risk models, and that the main problem arises as a result of the misanalysis of the effects of external and internal radiation because of this problem of anisotropy. Another example of anisotropy, for example, is substances which bind to DNA. Now, it's well known chemically that there are a number of chemical elements which bind to DNA. The backbone of DNA is stabilized by calcium. So members of the calcium group, like strontium and barium, will substitute for the calcium and bind to the DNA. Now, obviously, something that's radioactive on the DNA is going to be more dangerous than something that's radioactive that's not on the DNA. And yet, of course, the ICRP risk model just assumes, never mind about DNA, which wasn't even invented or discovered when the model was first put up. They just assume that you're a bag of water. I mean, they really do. There's a person-shaped bag of water, and the energy is just dissolved into it. So there's another area where it's easy to show theoretically that there can be an error in terms of the energy density of the DNA of up to 1,000 times. That's a big number, 1,000 times. But actually, that's the number that you find when you start to look at the epidemiology. So when you look around the nuclear sites, and the latest big study of nuclear sites was in Germany, carried out by the Childhood Cancer Registry in Germany, because the Green Party of Germany bounced them into doing this study, which they wouldn't otherwise have done. They found there was a statistically significant excess of childhood cancer within 5 kilometres of all nuclear sites in Germany over the whole period that they'd been run. And this was quite a big study. It was the biggest study of its kind. And although earlier we had found that people had found childhood leukemia clusters near other nuclear sites, notably from Sellafield and then to Aldermaston, and then there was one at Kattelerhaag and one at Doenray, and I've discovered them all over the place where there's nuclear. The point with the German study is that it was actually carried out by a government, and it's impossible to argue about the effects. But what they say is that the doses were too low to cause the effects, therefore it can't have been radiation. But as I pointed out just now, theoretically it's possible to show that there can be an error by about a factor of about 1,000, and they only need a factor of about 500 to explain these nuclear site clusters. So what I'm getting to here is that the normal operation of a nuclear power station, the normal operation, I'm not talking about it exploding, or I'm not talking about bad guys who let leaks out and don't tell you about it, or any of this stuff. Just standard operating of a nuclear power station kills people who live nearby. And in a study that we did recently, that the BBC presented on Points West, we found that there was also an increase in infant mortality in Burnham-on-Sea, downwind